Okay, so let's start out with a real simple concept. Let's say we had some water here. Some H2O. Why don't we say we have a half of a liter, which would be how many grams? 500. If 1 kilogram is a liter, right? So half. And by the way, your water bottles are typically half a liter. If you look at the side of them, it'll say 500 milliliters, which is half of a liter, which would be this. So we're going to take 500 grams of water. Let's put it at room temperature, which we typically define as about 20 degrees C. Okay, and we do know the specific heat of water, right? This is a number we're going to use a lot, so if you haven't already memorized it, I'm sure you will. What is the C for water?
4,180.
Okay, alright, so we're going to start this at room temperature. Alright, then we're going to take a piece of, let's say, some gold. Let's say we're going to have 800 grams of gold. And the C for gold is, I don't remember, 129. Okay, and let's heat this way up. Let's heat this up to, let's say, 200. Okay, so what am I going to do with this gold? So we're going to drop the gold into the water, right? And what's going to happen to the gold? Okay, it's going to sink, and then what's going to happen to the gold? It's going to cool down, right? The gold's going to cool down, and what's going to happen to the water? The water's going to heat up. And if you leave it in there long enough, what should happen to the temperature of both the gold and the water? Okay, they should balance out, right? And we have a name for that. What's that called? Equilibrium. So that would be the question, what is the equilibrium temperature? So what's the equilibrium temperature of the gold and the water? One of the things I would encourage you to do would be to predict like ahead of time, so when you get the answer you kind of know if you're right. If you were to predict this T final, what do you think it might be? 80 degrees? Okay. Someone else? 72? 64? 110? Okay, alright, so let's see what happens, and then we'll talk about the answer a little bit, because the answer will kind of solidify some concepts also. Okay, so what we're going to do is we're going to use the concept of energy and conservation, because what's going to happen to the heat energy of the gold? It's going to go into the water, right? So the gold is going to be losing energy, and that energy is going to go into the water, and so the water is going to be gaining energy, right? And if the gold lost 1,000 joules of energy, how much energy should the water gain? 1,000 joules of energy, right? So this is conservation of energy, and so that's how we're going to use it. That's what we're going to do. So we're going to phrase it like this, though. We're going to say the Q gained should equal the Q loss. And we're just going to add one little more piece here, and that's going to be a negative. Why am I adding a negative there?
Because Q loss is all.
Okay, Q, when you lose heat or remove heat, you have a negative value for heat. Okay, negative Q. So gaining heat is always positive, losing heat is always negative. Okay? Alright, so that's how we're going to approach it, and we know these should be equal to each other because energy is conserved. So 1,000 should equal negative 1,000. They'll be equal, right? So let's go ahead and do it. We're just going to use our equation now. So which of these two things is gaining heat? the water. So on this side we're going to say Q of the water, and then the gold is losing, so we'll say that should equal the negative Q of gold. Okay, and then what's the equation for Q? So we're going to write MC delta T for water, water, water. That should equal negative MC delta T for gold, gold, gold. Okay, so that's kind of the setup, and the concept again should be straightforward. You're just looking at what's gaining, what's losing, and then plug in the equations. So let's start substituting in the numbers. So the mass of the water was 500. So we are going to convert that, so 0.5. Okay, C for the water is 4180. The delta temperature, whenever you have a delta, what do? How do you subtract a delta? Final minus initial, right. So delta T is always T final minus T initial. So we don't know the final, that's what we're looking for, so we'll just leave that as TF. And then the initial temperature of the water was 20. Okay, that should equal, now don't forget this negative here, the mass of the gold was 0.8. C of the gold is 129. And again, we're going to go T final minus 200. Okay, so that's the setup. Probably the hardest part of this problem, honestly, is the algebra, doing the algebra here. So let's go ahead and multiply 0.5 times 4180 times TF. So what's that, 2090? Times TF. And then we'll multiply 0.5 times 4180 times negative 20. $41,800 equals. Okay, then we're going to do this. Now don't forget this negative up here, and this is the big mistake people always make. So this should be negative times 0.8 times 129 times TF. So this times this times this times this. It's going to give you a negative number. Help me out with this one. It's like 100, 103. Actually, here's where people make the big mistake. So now we're going to go negative times this times negative 200. So the negative negative will become positive. So 0.8 times 129 times 200. Two.
6 plus 0.
Okay, looks good. Let's finish up the algebra here. Get all these on one side, all the TFs on one side. Get all the non-TFs on one side. So we'll be adding 103.2 TF to both sides. We'll be adding 41.8 to both sides. So that's 2193.2 should equal 62440. Okay, moment of truth. Let's see how good our predictions were.
Yes.
28.5. Okay, so just reminder, a lot of your predictions were like 80 degrees, like 110 degrees, like 90 degrees. Why is this so low? Yeah, Layla.
It's so low because the specific capacity heat of water is so much higher than that of gold.
Okay, good. So you guys understand that? It's so much harder to heat up gold, takes so much more energy, water, so much more energy to heat up water than it does to heat up gold. Gold cools down really easily, heats up really easily, and water doesn't, right? About 20 times more when you compare the two. Actually, more than that, like 30 something times more. Okay, so the water barely increased and the gold decreased by a lot.